Okay, guys, so in class, I told you all that I will work out the first 5 problems for you all on the review sheet, and I will put those on YouTube. So we're getting ready to do that right now. Now, remember in class, I told you guys that there are 4 major kinematic equations in physics, and you're going to use one of these 4 kinematic equations to work out your particular word problem, whichever one it is that you're working on the test. So what I want to do, I want to show you guys how to use these four equations as we work through these 5 problems here. Now, the method that I'm going to use, I'm going to use the method that this guy uses in this video right here called Choosing Kinematic Equations, One-Dimensional Motion, and it is published by Khan Academy. So in this video, basically what he does, he writes down all the variables in every problem, and he looks at all the variables that are important to the problem in order to determine which of the 4 equations to use. So that's the method that I'm going to use. That's the approach I'm going to take whenever I solve these problems here. Now, if you guys want to go through this full video here before you guys take the exam, I would definitely recommend that. It's a pretty good idea. Also, guys, one thing that I want to say about convention, in these equations here, he uses delta x to represent displacement. Just note that I do something a little different in my equations. I just put d for displacement, whereas he uses delta x. So just a little note on convention. As long as you guys know what these terms mean, you should be fine. Okay. So again, we're going to work out the first 5 problems, and I'm going to go through this step by step with you all using his approach. Okay. So let's start with number 1. Number 1 says in 10 seconds, a car accelerates 3 meters per second. A car accelerates 3 meters per second squared to 90 meters per second. How fast was the car going before it accelerated? Okay, so I'm going to write out every variable that is important to this problem here, and this will give us an idea of which equation to use. So it says a car in 10 seconds. So 10 seconds is obviously the time, because just look at your units. It accelerates at 3 meters per second squared. Well, it accelerates at a rate of 3 meters per second squared. So if you see that meters per second squared, you know that it's obviously acceleration. So that's given in the problem. And the car accelerated to 90 meters per second. So 90 meters per second, if you look at those units represent velocity. And the car accelerated to that point, so that represents our final velocity. Okay. And it says, how fast was the car going before it accelerated? Before it accelerated. In other words, what we want to find here, we want to find our initial velocity. Okay. Now, guys, out of all the 5 variables in those equations, notice displacement is not even important to this problem. It's not listed anywhere in the question, and it's not even one of the things you're solving for. So displacement is not even important to this problem. It's not used at all in this problem. So that means we need to find an equation that contains all 4 of these variables, or all 4 of these terms here. And so if you notice, that is the very first equation. The very first equation includes all of those terms: the final velocity, the initial velocity, the acceleration, and the time. Of course, and of course, what we're looking for, we're trying to find initial velocity. So I'm going to write that equation out, and we're going to use this equation to solve this problem here. Final velocity is equal to initial velocity plus acceleration times t. Okay. So now let's just plug everything in and go through the math. So the final velocity is 90 meters per second. Okay. The initial velocity is what we're trying to find. We're given the acceleration, which is 3 meters per second squared, and the time is 10 seconds. Okay. Now from here, it's just algebra, because we're trying to solve for the initial velocity. Okay. As you guys know, 3 times 10 is 30. Okay. Now, how do we solve this equation for the initial velocity? That's what we got to get by itself, so I'm going to need to get rid of this 30 and put it on the other side equal sign. So I'm going to subtract 30. That goes away. Whatever is one side, I have to do to the other. So I'm just left with 90 minus 30 is just 60. So 60 meters per second is equal to my initial velocity. Okay. And there you go, guys. That is number 1. Okay. Hopefully that makes sense. Let us move on to number 2. Number 2 says a car is initially at rest and then begins accelerating until it travels a distance of 50 meters. It has an acceleration of 2 meters per second squared. How long did it take to travel this distance? Okay, how long did it take to travel this distance? So let us list everything that's important to the problem. It says the car is initially at rest. So y'all know what rest means. Rest means the initial velocity was 0 meters per second. That was its initial velocity. And then it begins accelerating until it travels a distance of 50 meters. Okay, so we're given the displacement, or in other words, the distance covered, which is 50 meters. Okay, so, just, look at your units in order to determine which equation to use. So 50 meters represents the displacement. It has an acceleration of 2 meters per second squared. So 2 meters per second squared. Okay, that's clearly our acceleration. Okay. How long did it take to travel this distance? Okay, so guys, if you notice, according to everything that's given, final velocity is not even important to this problem. So it's not even used at all in this problem. So since it's not important to this problem, we need to find our equation that basically includes all 4 of these variables here. So which equation includes displacement, initial velocity, acceleration, and time? Well, if you notice, that's actually the second equation, the equation in red. Includes displacement, initial velocity, time, and acceleration. So that's the equation we're going to use. So I'm going to go ahead and write that out, and then we're going to go through the algebra. Okay, so displacement is equal to initial velocity times t plus 1/2 multiply acceleration times t squared. Okay, so let's just plug everything in. 50 meters is our displacement. And by the way, our initial velocity is 0. So if we plug in 0 here, 0 times some number is just 0. So this whole thing here just becomes 0 because our initial velocity is 0. Plus, in here I'm going to put 0.5 because 1/2 is equal to 0.5. 0.5 times 2 okay. 0.5 times 2, all of that multiplied by t squared. Okay, so 0.5 times 2 times t squared. Okay, now guys, let's just simplify this so we can do the algebra and solve for t, because that's what we're looking for. We're trying to find time. By the way, guys, 0.5 times 2, that's just equal to 1, right? So 1 times t squared. So in other words, what we're trying to find here is just to get t by itself. In order to do that, we have to take the square root of this. So that squared goes away. Whatever you do on one side of the equation, you have to do to the other. So the square root of 50 is, the square root of 50 is equal to 7.07 seconds. Okay. So that is our answer for number 2. Okay. Hopefully that makes sense. let us move on to number 3. Okay. Number 3 says a car is not a car, but an object is moving at 15 meters per second. 15 meters per second. It experiences acceleration of 5 meters per second squared for 15 seconds. How far did it move in that time? Okay, so guys, let us list everything that's important in this problem here. It says cars moving at 15 meters per second. So that is the initial velocity. So it's moving at 15 meters per second. And then it experienced an acceleration of 5 meters per second squared. So that's our acceleration. And it did this for 15 seconds. Okay. And how far did it move in that time? In other words, we're trying to find displacement. Okay, so I'm going to put a question mark there because we're trying to find displacement. Okay, now, if you guys notice, final velocity was not mentioned anywhere in this problem. So that means final velocity is not even important to this problem here. So we can cross out that because final velocity is used. We basically want to find an equation that relates all of these terms, displacement, initial velocity, acceleration times time. And once again, that is this second equation here, the equation in red, because in this equation, notice final velocity is not even listed in this equation. So, but all the other variables are. So we're going to use this equation here, this equation in red, to solve this problem. So I'm going to write that out, and then we're going to go through the math. So displacement is equal to initial velocity times t plus 1/2 at squared. Okay. So displacement is what we're looking for. Okay. We're given the initial velocity, which is 15. The time is 15 seconds. Okay, so time is 15 seconds. That's what they told us in the problem. Plus, remember, 1/2 is the same thing as 0.5. Okay, 0.5. The acceleration is 5 meters per second squared. Okay, and the time is 15. And remember, the time gets squared according to our equation here. So we square our time. Okay, so now the rest is just using your calculator. Okay, 15 times 15 is 225. Okay, so in my calculator, I'm going to put 15 squared in my calculator. 15 squared, and I'm going to multiply that by 5, and I'll multiply that by 0.5. Okay. That gives me 562.5. Okay. Now, when I add those together, I get 787.5 meters. Okay, guys, so that is my displacement for number 3. In other words, that's how far the object moved in that time. Okay. So 2 more. We're going to finish this up with number 4 and number 5. Okay. So in number 4, it says a rocket climbs 100 meters in 3 seconds. It was moving 15 meters per second to begin with. What is its final velocity? Okay. So let us write everything out here. Okay. So it says the rocket climbs 100 meters. So that's obviously our displacement. Okay. And it did that in 3 seconds. So 3 seconds is our time. Okay. And it was moving at 15 meters per second to begin with. So that was our initial velocity. And of course, we're trying to solve for the final velocity. Okay. So if you guys notice, acceleration is not even important to this problem. acceleration was not even mentioned in the problem, and it's not even something you're trying to find. You're trying to find the final velocity here, not the acceleration. So the acceleration is not even important in this problem. It's not what we're looking for. Neither is it something that we're given. So the acceleration is not important. So we need to find an equation that does not include acceleration. So if you notice here, going back to this, that looks like we're going to use our equation here in blue. Okay, we're going to use our equation here in blue. And what are we trying to find? We're trying to find the final velocity. Okay. So I'm going to write out this equation here in blue. Displacement is equal to initial velocity plus final velocity divided by 2. All of that gets multiplied by time. Okay. So let us just plug everything in and go through the algebra. Okay. So the displacement is 100. The initial velocity is 15. Plus the final velocity, that's what we're trying to find, divided by 2. And of course, all of that multiplied by 3 seconds, which is our time. Okay. So guys, we need to go through some algebra here in order to find the final velocity. Okay? Because the goal is to manipulate this equation here. And, the goal is to get final velocity by itself. Right here, that's the goal. Okay, so in order to do that, okay, first thing I need to do, I need to get rid of this 3 here. Notice 3 is multiplied by, everything on the right-hand side of the equal sign. So since it's multiplied, I need to do the opposite of multiplication to get rid of that. So everything on the right-hand side, I need to divide by 3. And if I divide by 3, that goes away. Okay. Remember, whatever you do to one side, you have to do to the other. Okay. So 100 gets divided by 3. And 100 divided by 3 is equal to 33.33. All of that is equal to all that is equal to 15 plus our final velocity divided by 2. Okay. Now, guys, let us keep going. So, in order to get this final velocity by itself, the next step we need to do, we need to do the opposite of division in order to get rid of this 2 here. Okay. So the opposite of division is multiplication. So I'm going to multiply by 2, and that goes away. Remember, whatever you do to one side, you have to do to the other. So this side, I'm going to multiply by 2. So 2 times 3, 33.33 gives me 66.67. All that is equal to 15 plus final velocity. Okay. So guys, we're almost done here. In order to solve for final velocity, we're going to have to get rid of this 15. So we have to do the opposite of addition, which means we're going to have to subtract 15. Whatever you do to one side of the equation, we have to do to the other. So when we do that, we are left with 51.67. Just rounding that out to 51.67 meters per second for my final velocity. Okay. So that's how you do number 4. Okay. Hopefully that makes sense. Last one we're going to do. Last one. This last problem says an object at rest starts accelerating. If it travels 110 meters to end up going 30 meters per second, what is its acceleration? Okay, so it says an object starts at rest, or whether it says an object at rest starts accelerating. So if it starts off from rest, you guys know what this initial velocity is going to be. Its initial velocity is just 0 because it starts off at rest and it travels 110 meters. So that's the displacement. The displacement is 110 meters. Okay, that's given. And it ends up going 30 meters per second. So it ends up going 30 meters per second means that's its final velocity. So looking at our units here, 30 meters per second is our final velocity. Okay. And the question says, what is its acceleration? That is what we're trying to find. Okay. Now, if you guys notice, time is not given anywhere. Time is not given anywhere in this problem. Neither is it something that we're trying to solve for. In fact, we're trying to solve for acceleration. So time is not even important to this problem. I'm going to cross this out. Time is not important at all, which means we need to find an equation that includes all 4 of these terms here. So we need to find an equation that includes displacement, initial velocity, final velocity, and acceleration. Of course, acceleration is important because that's what we're trying to find. So which equation includes all 4 of these terms but does not include time? Well, what do you know? That would be this equation here in green, this very last equation. Okay, so I'm going to write this out and we're going to use this equation to solve for acceleration. So final velocity squared is equal to initial velocity plus 2 times acceleration times displacement. Okay, so now let's just plug everything in. Final velocity is 30, and of course that gets squared. The initial velocity is just 0. Plug in 0 to the equation. 2 times acceleration times our displacement of 110. Okay. So, okay, guys, the rest here is just algebra. We want to use algebra here to solve for the acceleration. Okay, so that is our goal. Okay, so 30 squared, that is equivalent to 900. Okay, and of course, guys, 0 squared, you know what 0 squared is. 0 squared is just 0. Okay, so 2 times acceleration times 110. I want to take 2 and multiply by 110. So this 2 here, multiply by 110. Okay, so I get 220 times A. Now, lastly, in order to get A by itself, we just have to divide the right-hand side by 220. That goes away. Whatever to one side, we have to do to the other. And when we do that, we're left with 4.09 meters per second squared for the magnitude of our acceleration. Of course, that is number 5. Okay. All right, guys, if y'all have any questions on any of these problems or any of the problems, please either contact me over Schoology, send me a message or send me an email, or you can join the Zoom call during class time. Okay. Remember, I'm going to have the Zoom call open during class time in case you guys have any questions. Also, guys, one more thing that I want to say: if it gives you a problem and it gives you a final velocity, but doesn't necessarily tell you what the initial velocity is, it's okay to assume the initial velocity is 0. Depending on the problem. Okay, guys. So that's pretty much all I have. I'm going to stop this video, and like I said, contact me if you guys have any questions. Goodbye.